talk. This is actually my second time in New Zealand. The first time I was in New Zealand, New Zealand has been bringing out kind of the extreme adventure side of me. So I have a little video that shows you what I did the last time I was here. So the best part is yet to come. All right, so thank you, New Zealand, for bringing out the adventure in me. And it really has created this desire in me to live on the edge, including even living outside the IDE, which is what we're going to talk about today. So just to recap, or just to give a summary of what we're going to cover, we're going to talk about what scriptcs is and why it exists, how to get it, the basics of how to use it, how to put the pedal to the metal. What can you do with it once you really understand those basics? So jumping in, and before I get started, I'll just give a quick thing about me. So I work at Microsoft. I've been there for about 8 years, and I work on the Windows Azure platform. And scriptcs is a side project that I work on. It's not actually part of what I get paid for. But it does use the .NET platform, which I guess I do get paid for. C#. I've been using C# for about 10 years, since the .NET betas. And C# is amazing, really powerful platform. But sometimes the development experience feels a little heavy to me. And what I'm talking about is sometimes what I want to do is just play with some code. I want to invoke some APIs or try something out and just see how it works. And in order to do that, there's a lot that I have to do. I have to open up Visual Studio, create a project, figure out what kind of project I'm going to create. If it's going to be a console app, I have to create a main method, or if it's going to be a unit test, then I'm going to have to create a unit test project, run through a test runner. It's just a lot of steps, not to mention that I get hundreds of files on my machine just for the most simplest app. Now, that's not to say that Visual Studio is bad. Let me say really clearly, I'm not at all saying that Visual Studio is bad. But what I am saying is for that kind of workflow where I just want to try some simple things, it can sometimes feel heavy. Other cases that I've seen over the years are maybe I wanted to do some simple automation. And I found myself creating, you guys have all done this, like console app 1 through 100 or some WPF app, when all I really want to do is run a minimal set of code. So I started to think, could there be some type of low-cal option? Again, not a replacement for Visual Studio, but an alternative. And this got really intensified, this desire for this, because I noticed as I started to look outside of .NET that when we look at other languages, particularly dynamic languages, we see that Ruby, Python, and Node.js as examples all have this ability to just open up an editor, write a couple of lines of code, or even use a REPL where I can just interactively start typing code and APIs and seeing the results. And the one that really struck it for me was Node, because I spent about 2 years working on Microsoft's story for supporting Node.js development in Windows Azure. Has anyone here heard of Node.js? Okay, so you're already familiar with it. So when we look at the Node developer experience, with Node you install this very small core, which you could even bin deploy if you're on a Windows machine. It's just a simple exe, and it has a bunch of functionality in the box, but not too much. And I can simply open up a text editor and start writing my first Node program. Or I can use the REPL, the reapply eval print loop, which is the interactive way to enter that code. And that's a really fast experience just to get going. And then when I want other things, I go to NPM, the Node Package Manager. And there are 40,000 modules and growing in the Node Package Manager. And I can very simply install them using a command line tool called npm. And I can just go in a folder and say npm install, say, Express, for example, which you'll see more on this in Ian Randall's talk if you're not familiar with Node, where he'll be speaking about the Node.js developer experience in general. I can go and install that module. Everything is local. It's very easy to manage, and I can work with it. And then I can start to add other modules all incrementally. But I don't need to be in an IDE. Most Node developers are not actually working from an IDE. They use text editors, like Sublime Text, which is the one that I tend to use. There's Emacs. There's Vim. There are IDEs, but the point is you don't need it. There's no required project system. It's just really a set of loose files that get brought together. So no IDE required, no project, minimum install. Everything else outside of the core is a package that is easily installable. That is the Node experience. And Ruby has a similar experience. If you do like Ruby on Rails, you'll have something similar, Python, something similar. So then I looked at C# now, seeing how things have progressed. I said, well, for the packaging story, we actually have quite a nice packaging manager now. And it's called NuGet. And there are thousands of packages out there, and there are packages from the community and packages that Microsoft itself is contributing. So there's that really rich ecosystem that you can get to from packages. As a matter of fact, today, pretty much like any kind of ASP.NET application you build, you'll be pulling in NuGet. And NuGet is really the future for Microsoft. How many people here are using NuGet? So you already know this. I'm preaching to the choir. But then there's the question of what about the project? What about the project system? Is there a way that I could just run some C# code really simply? And in the past, we have had a utility that's included in the .NET SDK called CSC. And as a matter of fact, that is what Visual Studio uses today when you go and build like a C# project. It's going to call CSC, which is a command line tool that will build that C# file. But it's not really the kind of tool that has a great experience for me to do it manually. I have to specify all my DLL dependencies and add those in the command line. I still have to have an entry point and other kinds of things. Then I would build a DLL, but how do I invoke that DLL? So it's not an ideal kind of experience. But it turns out that there's a new technology on the horizon, new sheriff in town, called Roslyn. And Roslyn is compiler as a service. What it allows you to do is basically take a C# file and turn it into a DLL. No need for a project. But what Roslyn has that's also interesting, and this is where the scriptcs angle comes in, is it introduces a way to do C# script. You can do procedural code. You don't have to have classes. You can have classes, but you can get going just doing the most basic procedural code, and then you can grow into something that's more sophisticated. So cool. So now I have a way to be able to take the C# code or write lightweight C# code without a project, and I've got a packaging system. But what's missing is the combination of the two. The two technologies don't have a bridge between them. So I could go and install some NuGet packages, and I could go and use Roslyn, but then I have to go through a lot of hoops to get Roslyn to load those packages for me. And I end up asking myself, is this really worth it? I might as well just go to Visual Studio. This is kind of self-defeating. And that is where scriptcs comes in. Scriptcs is designed to give the end-to-end experience combining Roslyn and NuGet so that I can easily write scripts utilizing packages. And it removes a lot of monotony, which you'll see, and heavily relies on convention so that you really have to do less work to leverage both. And it satisfies the same criteria, or it delivers on the same kind of benefits that you get with the Node experience. You don't need to use an IDE. You won't see me using an IDE except once. You don't need a project. It's a minimum install, and everything else is a package. I'm just going to swap over to shut something. Yes, it is a Mac. The dirty secret is out. So that's scriptcs. So let's just jump in. Now, to get scriptcs, the easiest way to get it is using Chocolatey. And Chocolatey is a place, it's a great tool for installing command line tools, but you can install lots of things with Chocolatey. It's really an app, kind of an app manager like you have in many different platforms, like apt-get in Linux, for example. And if you go to chocolatey.org, you can search on scriptcs, and it will give you the one-line command that you need, cinst scriptcs to install scriptcs. Installing Chocolatey is also one line, so if you don't have it, it's really easy to get it. So let's go see what the basic experience is of working with scriptcs and what it will do for us. So I'm going to open up a PowerShell prompt. And you don't have to be in PowerShell to use scriptcs. I've just gotten very comfortable with PowerShell. OK, so I've got an empty folder here. And what I'm going to do is I'm going to use Sublime Text. And I'm going to create a start.csx. The reason I'm using that start command in PowerShell is so that it won't block. Normally, when you just launch an editor or launch an exe, if you just launch it, then it's basically going to block. You won't be able to access anything from the shell, but I want to, so I'm going to do that. OK, so I'm just going to do the basic thing. Console.writeLine, hello from scriptcs. And by the way, it is lowercase. The name is lowercase. The namespaces, because we follow proper namespacing rules, get capital, but it is deliberately lowercase. OK, so now what I can do is say scriptcs start.csx. And we can see it says hello from scriptcs. Now, I can do much more than that. I can create variables, for example. I could say var a equals hello from scriptcs. And then I could output that variable. Same thing. So one of the things that you notice here is there's no class, there's no namespace, there's no usings. And that is because we've taken the most common usings that you would need to use for, say, a console app, and we've made those things available. I'll get into how you can access other kinds of namespaces and things. But it's procedural. And when you're doing tinkering and things like that, why do I need a class? Why do I need a method? All I want to do is just call some APIs, like I'm doing right here. Of course, I probably want to do more than just writing to the console. OK, so that is hello scriptcs. But we can go much further than this. This by itself would not be that interesting. So what we can do is we can now take this console.writeLine and we can wrap it into a function. Actually, I don't think we even need a public. Let me test that before I. So I can say greet, string, message. By the way, for those of you who've never seen this editor, this is Sublime Text. Let me give it an official introduction. No applause necessary. So now what I'm going to do is I'm going to write out the message that was passed to the greet function, and I'm just going to call it. Order doesn't actually matter when it comes to procedural code versus functions in scriptcs and in Roslyn. So I don't have to actually put the call after the definition of the function. So I'm just going to say greet hello from scriptcs. This might fail because I didn't put a modifier. I want to see what's going to happen. And if it shows us an error, then you'll see what error handling looks like. So that works out. OK, so I have hello from scriptcs, and then I've got console writeLine message. Right, so that failed. And I think that's because of the fact that I don't have a public here. Public void string. Let's see, greet. Oh, it's a void. That's why. I put public void string. Not enough sleep. OK, let's try that again. I think that actually should work. Yeah, there we go. So now I have a function. So I can have a bunch of loose functions, and I can just now call them. The story's going to get better, trust me. Now what I could do is say, well, you know, I got a bunch of functions, but really what I want to have is a class. Or maybe I need to have a class because I'm calling some API that requires me to give it a class, like a model or something like that. So now what I can do is say public class greeter. And now I can say var greeter equals to new greeter, greeter.greet. Nope. What did I do wrong there? Inaccessible. Public, because now it's a class, so it needs to be public, so I can call it from the outside. So what you're seeing there, this is a good segue, is what happens when things fail. You get the error. You get the same error, basically, that you would have gotten in Visual Studio or running your app at runtime. So you're not losing the information. Now, of course, it's not as pretty because of the fact that we're running at the console. It used to be red. I think something must have changed. It used to come out red. Oh, and the replit comes out red. Correct. That's right. OK. So let's try it again. So we see that it works. So you're seeing the incremental flow here of how I'm able to start off with just loose code, introduce functions, introduce classes. So I can really kind of grow up. Now, one thing that's going to happen, though, well, first let me point out something. Have you noticed that that text is colored? There's syntax highlighting there. So they're actually, Sublime Text actually has plugins. And there is a scriptcs plugin for Sublime Text that one of our contributors wrote that will give you this nice syntax highlighting. It also will allow you to run scriptcs code right from within Sublime, and it will just show you the output, which is also nice. So if I look in Tools here, let's see. Where is it? Oh, yeah. I have a build system here, and I can build scriptcs, and it will run it. I don't remember the keystroke right now, but anyway. OK, so now the challenge we have now is, over time, my file is going to get very big. So when I use things like JavaScript, JavaScript has a require command. And with the require command, I can split things out into separate files. So it would be nice if I could do that as well for scriptcs. And we actually have the ability to do that through a directive called #load. So what I'm going to do is close this and open the directory in Sublime. And I'm going to add a file called greeter.csx. And I'm going to copy the greeter class into that file. And then I'm going to save that as greeter.csx. CSX is the extension that Roslyn uses for Roslyn script files. So I'm going to keep the code the same. The only difference is I'm going to add on top this #load, and I'm going to say load greeter.csx. Oh, I forgot to see. That's what happens when you forget to do the start, what you just saw. I couldn't enter anything. OK, let's try it again. So basically, same code worked, but now I was able to factor it out into separate script files. So I could basically start to have a library of different scripts that I could reuse. I could put it in some central folder or relative folder. It is recursive, so all those scripts can each have their own #loads within them. What you can't do, which you might be wondering, is can I embed code within the body? The answer is no. And that is because we have stuck with, as much as possible, the Roslyn specification. And the Roslyn specification says that #load should always be at the very top of the file. So you're going to use this to bring in libraries. You're not going to use this to kind of dynamically modify the file or give an empty class, function definition and have it plug the body in. Any questions on this so far? OK. So let's go further. So we've got our greeter here. Let's say I wanted to use something like ADO.NET. Now that is in a DLL called system.data. And that DLL is in the global assembly cache. So with Roslyn, I can actually reference things in the global assembly cache. For example, I could say reference system.data, and I could say using system.data. Those are two different things. The reference is saying, get me the DLL out of the global assembly cache. The using is saying, I want to actually now use this within my application. Oh, it failed there. Did I? Oh, see? Because I moved pound load below. It has to be the first. We should probably add some validation, though, that actually says, hey, by the way, you've got a pound load out of order. So this is good. We just found a bug that we can file. OK, so we see that worked. And we know that it worked because if I put another namespace that doesn't exist, it will fail because it doesn't recognize that using that namespace. And then I could do things also like access the HTTP client that is built in .NET 4.5. So I could reference system.net.http, and I could use system.net HTTP. And then I would be able to do things like access the new HTTP client that ships with .NET 4.5. So we see that it all worked. I'm not using the client yet. I will actually show you using the client shortly. OK, so you're starting to get this? What's possible here? So let's see how we could put this all together now. Just what we've seen so far, which is the ability to reference things from the global assembly cache and the ability to create classes and functions and things like that. So what we're going to do is going to be very interesting. I promise you, you will think this is interesting. So we have a set of samples that are available in our repo. This project is also available on GitHub. It is open source. So I'm going to go into this WPF folder. And now what I'm going to do is do scriptcs start.csx. So I have a WPF calculator that has completely been authored in script. So there's no project file. I'm loading a loose XAML file using the APIs that are built into the .NET framework. And I'm using a view model. Now, this is really just to illustrate the kind of things that are possible. Would you go and build a harness this way? Maybe, maybe not. You can see here that I have a standard view model for those of you that are familiar with WPF and MVVM patterns. I have a function that is loading up XAML. Now that function is actually something that I've included, and I'm using pound loads to bring this in. We'll talk about how this kind of thing can be simplified. Right now I have to write some of this boilerplate code. And if I go into the entry point, you can see that I've got a bunch of GACT assemblies that I'm referencing, including the WPF assemblies, and I've got a bunch of pound loads. One of the nice things this model opens up is the fact that you could put all your usings in a single file. So some of the samples out there will actually have a usings.csx that is just included. Now why this works is because all of these scripts actually get combined into a single class. The way that Roslyn is able to support this procedural code model is it will actually create an outer class that everything else goes in. And it takes the procedural code and it actually puts it in a function that Roslyn, the engine, knows to run in the right order. So because of that, you can take advantage of saying, hey, I'll just put all my usings in one place and they will all trickle down into all the files. Did you have a question? Anyone have any questions before I move on? OK, so a common thing that people will say when they see an app like this that is spanned across multiple files is, what do I do when things fail? Is there a way that I can debug? So you actually can debug by adding things like console.writeLine. But of course I could do that. That's like the ASP 1.0 days. Is there something else? Now, there actually is, and it turns out that we've done some work that enables you to actually be able to debug this in Visual Studio. Today, there's a little bit of setup to do it. It's posted on a wiki. I'm just going to show you what it looks like when you do it. And I'm not going to do it for you because we don't have enough time. But I'm going to open Visual Studio, and you're going to see so one of the things you can do in Visual Studio that a lot of people don't know is you can actually open a project and point to an exe. So the way you do this is you actually open up scriptcs exe itself. You create a new project, you do open project, and you point to an exe. And you get something like this without these solution items in it. And if I right-click on this, it gives me a dialog where I can enter some information. So this is the executable, which is what Chocolatey installed on my machine. I've already set this up, as you can see. In the arguments, I put the name of the start file that I want scriptcs to run, and I pass this -debug. This is very important. If you don't pass debug, it will not be debuggable. It has to do with how we compile it and symbols and other stuff. And then the last thing I need to do, which is also very important, is to set the working directory. Because what it's going to basically do is launch scriptcs. And when you give scriptcs a file, it expects that that file is actually relative to the path where you're running this. So once I do that, though, I can now actually have breakpoints within the app. Now, one of the things you'll notice here, too, is it's color-coded to some degree within Visual Studio. Why is that? Roslyn has a CTP that is available as a Visual Studio extension. And if you install it, it will actually understand to some degree, it will understand the CSX format, and it will give you some color coding. We do some extra things in scriptcs, which is why it doesn't know how to find that calculator view model. So now I've got a breakpoint here on the calculator view. So I'm going to run it, and you're going to see that it's actually going to break. That message is expected. So here you go. So I can step through any one of the files within my script project. So here is a good example of where we're saying, hey, as I'm writing, I may not feel like I need Visual Studio, but if I get to a place where I'm having trouble figuring out what's going on or I want to step through it, I have that option to move into VS. Now, granted, this experience today is not as great as it should be, and we want to improve that, but there at least is a path. You're not stuck in the water. And once you get this project set up, like you'll notice here I saved this solution as scriptcs debug, you pretty much have to only do that once, and then you just keep reusing that when you want to debug. All right, so we've seen a bunch of stuff that I can do now within the context of files. But I mentioned that you don't always want files. If you look at a lot of these other frameworks that are, these other language stacks that are out there, you actually have this thing called a REPL. And from the REPL, you can actually do these interactive commands. Well, scriptcs actually has a REPL as well. So what I can do is I can just run scriptcs by itself. And if I run scriptcs by itself, I can now say console.writeLine hello. I can create variables, var a equals foo, and I can output that variable. And because it's a REPL, we've added some extras, like if you just type the variable name, it's going to dump that. I can even pound load from within the REPL. So I can say pound load greeter.csx var greeter equals to new greeter. And then I can say greeter.greet hello. So I get kind of the best of both worlds. Now let's go to that example of using HTTP client. So I'm going to say pound r system.net.http, and then I'm going to say using system.net.http, and then I'm going to say var client equals to new HTTP client. Now here's where we're going to hit a little bit of a snag, because the HTTP client uses tasks. And in .NET 4.5, we have async await. One of the things that the Roslyn CTP does not support today is async await. This is a point-in-time thing. In the future, it will. But there's an easy way to work around that, which you'll see me do right now. So I'm going to say client.getAsync, and I'm going to call, I'm going to give it a URL, so www.bing.com. And you can tell I work at Microsoft. And then what I'm going to do is access the result of the task, which will force it immediately to return the response. It's not going to run async. It's basically going to run sync. So I used HTTP client to call out to APIs. So imagine you're doing your own API development within your company, or you're consuming other types of APIs, and you want to just experiment with stuff. Fiddler's great when you want to do pure HTTP requests. But using this, you can interactively work with HTTP client, instantiate your own models, and work with them and manipulate them programmatically, run your own functions. So it gives you a lot of flexibility from the REPL. And as you can see, I was able to do #R as well from the REPL. So you can write code in the REPL or standalone. You don't have to have a class. You can write pure procedural code. And you can even do in the middle by just creating loose functions. But you can grow to have a full class if you want to. You can span out and break your files up into other files using #load. And we really see this as more of an incremental flow. Like you can follow this path and start off with the simplest, easiest, and then you can grow as you need to. You can reference assemblies, including GAC assemblies. So I only showed you referencing GAC assemblies, but you can drop binaries into a bin folder or any other folder, and you can reference those as well. But you'll see soon how you probably won't need to. This last one we didn't see, but you can actually access command line arguments. So a common pattern would be to create command line tools. And for those command line tools, what I want is the user to be able to run the script and pass a parameter. So I could do this for, say, automation. This is common for like an automation scenario. So I'll just show you quickly what that would look like. So we'll go back to, well, we'll close out Visual Studio. Bye, Visual Studio. So, so what I'm going to do is get rid of this, because I don't need this anymore. And instead of doing greeter.greet hello from scriptcs, I'm going to actually access a collection that we offer you called scriptargs. Now, scriptcs has its own parameters. You can pass it for log levels and other kinds of things. Scriptargs is a special collection that allows you to get access to just the custom parameters that are being passed in, which are not the native scriptcs parameters. So the way that you specify custom parameters is you use this, there's a kind of convention, you have to use --. Anything after ---- will be considered a custom parameter so that we can clearly separate it. So this opens up a lot, because now you can actually create full-fledged command line tools using scriptcs. You could package that up into a batch file. That's your name. Scriptcs just becomes an implementation detail. Now, one thing that this is important to segue into is a lot of people see this and say, well, I have PowerShell. How does this differ? Is this trying to replace PowerShell? It is not trying to replace PowerShell. However, it's important to mention that PowerShell is a completely different type of language. And the power of scriptcs is that if you are a developer and you know C#, you already know how to use scriptcs. But that is not mutually exclusive with saying that everything that you can do with scriptcs, that everything you can do with PowerShell, you can do with scriptcs. They're not trying to solve the same problem. But that being said, a lot of people are looking at it and saying, I can do my automation tasks that I need to using C#. Or maybe I even have some existing functions that we use that I can just leverage. And I say, there's nothing wrong with that. But I want to make it clear, that the goal here is not to try to unseat or replace PowerShell. And I can tell you that pure admins are not going to want to go near this, and that's fine. Okay, so that is the basics of scriptcs. So where do you go next? Well, what about the package thing? I said that the real power here of scriptcs is the fact that I can write the code, but then I can pull in packages. And there's tons of packages that are out there. So one such package is MongoDB. MongoDB is a great package that allows me to, it gives me a MongoDB client if I want to talk to a Mongo database. Anyone here using Mongo, using NoSQL type databases? Okay, you can think of the same thing for like SQL client, but the SQL client is built in, so it's not exactly the same. So scriptcs allows you to work with packages in a very natural way. We actually have a command, scriptcs-install. And when you use scriptcs-install, you can install any package that is available in NuGet. So I'll make a folder here called MongoDB. And I'm going to say scriptcs-install MongoDB. Okay, so it says it went and found MongoDB and it added it locally. I might want to take this code that I'm writing and share it. So it's usually frowned upon, and it's not a great practice to upload all your packages into GitHub, like if you were going to share a repo, or imagine you were going to share this as a gist. So what we do is we automatically create for you a packages.config if it doesn't exist, and we will update the packages.config if it does exist. And what that allows us to do is, what that allows me to do is go and delete the packages folder. And then if I pass this off to my friend with just my scripts and my packages.config, I can do scriptcs-install. It will go and automatically pull down whatever packages were defined within the packages.config. So now I want to use MongoDB. So in the same way that before I showed you I could write code in the REPL or I could write code in script, I can actually use this right from the REPL. So what I'm going to do is I'm going to just run scriptcs. And what it's going to do is, by convention, it's going to look in the local packages folder. So what happened was, when I went and installed this, what we do, which is very similar to kind of the node model, is we create a local packages folder, and that's where the packages are. And scriptcs, by convention, will look for that, and if it sees it, it will take all those packages and it will load them up. It will find the correct assemblies and load them. So if that's true, I should be able to do this. And I could. So what's really nice here is, before you saw when I was using the GAC, I have to put $r and specify the name. I don't have to do that here. Because of the fact that the package is present, we'll load it for you. And why that's also nice is, if we didn't have this kind of feature, you'd be doing a $r and you'd be having to manage copying the files into the right place or putting some really long path names into your script, and you don't have IntelliSense and all this other stuff, so that just becomes a non-starter. So we wanted to make it so this is a starter. So that's the experience. So now what I could do is new up a bsun document, and you can see that I now actually got a real object. I could do doc.getType. We can see that it is a MongoDB bsun document. So I can now use any NuGet package, basically, that's available out there. Simply by using scriptcs-install, I can use it in my scripts. I can use it in the REPL. So now, if we go to putting this together, well, first off, just to summarize, so I can install any NuGet package. I can install a set of packages via packages.config. That first point is really important. You notice I didn't have to go and install NuGet. Well, you don't notice because it was already installed. I didn't have to go and install NuGet. NuGet has made the NuGet libraries that NuGet itself uses available as NuGet packages. So scriptcs itself pulls in the NuGet scriptcs, the NuGet packages, so that it can talk to NuGet for you, thus not requiring you to have NuGet.exe installed on the machine. It will install all the packages and dependencies locally. There's no like global assembly cache or anything like that. We do have a notion in scriptcs of global modules, which are where you actually want them to be global because they modify scriptcs itself. I'm not going to delve into that in this talk. And you can see that they're automatically loaded. All I've got to do is add a using statement, and they work. So let's see another example of scriptcs in action, putting all of this together, including NuGet. So there's a very cool NuGet package that I had something to do with. It's called Web API. Anybody here heard of Web API? Okay, I was on the Web API team way back when. I forgot a T. Okay. So what I can do is I can actually self-host completely from script a Web API using the Web API NuGet packages. So if you look here, you'll see that I have previously installed Web API's self-host. And first I'll run it, and then I'll show you what it does. That's a really long path, but anyway. So I'm going to say scriptcs.start. And then it tells me, hey, I've got a server that's listening. I'm going to use Chrome only because it will display. OK, so what I have here is API/test. Let's see if that's it. Oh, wait, hold on a minute here. It's 8080, I think. So we can see hello world. So this is a web API that is hosted completely in script and using NuGet packages. So just to see what that means, if we go into Sublime Text here, we can see that I've got a bunch of using statements. I am having to still put the using statements for web API. That's not taken care of for me magically yet, meaning in about 5 minutes it will be, but I'll get there and show you that. But I have to basically put all that stuff in manually. And then I'm creating an HTTP self-host server. Now, I need a config object to do that, which is living in this web API config down here. You can see that I'm newing up an HTTP self-host configuration. And then I have to map my routes. Now, you might say, well, why do I have to do that? And I agree with you. But in Visual Studio, it will do this for you. So if you create a web API project, it will automatically set up the default routes for you. And then I have to do this thing called a custom controller resolver, type resolver. And that's because Roslyn compiles assemblies into memory. And it emits a dynamic assembly by default. It can write to disk. But by default, we didn't have it writing to disk. We've actually since changed that, but this is the current version. And so what happens is that a lot of the frameworks that are out there, like Nancy and Web API, were not designed to deal with dynamic emitted assemblies. So what you have to do here is there's a little bit of boilerplate, which could be put into a separate script to do that for you. But the point is, it all works. And here's my controller. Just a standard Web API controller. Now, there's a ton of other samples. Sorry. There's a ton of other samples that are out there. So if I go to github.com, scriptcs, which is our organization on GitHub, you'll see that we have a GitHub scriptcs samples repo. And people have been creating some really interesting samples. Fluent Automation, for example, lets you use Selenium to do browser-based testing. And he has a Fluent API. So he was like, it'd be perfect to just write that as script. Why do I need to create a project just to specify this declarative syntax for testing? So he found that to be really good, but there's a ton of other ones, all the popular web frameworks, Nancy, for example. There's a RavenDB self-host sample. There's a lot of things you can do with this. And there's a new one that just popped up, which I'm going to switch over to my Mac for a second. And this is really, really cool. Someone has gone ahead and created a layer for working with Arduino. Now, this is a preview of something we're about to get into, but I'll just show you the video because it's pretty cool. So he's using Sublime, and he's basically, from script, talking to an Arduino and controlling it. And he built a library to make that better, which we're going to get into in a second. We're not going to get into his library, but we're going to get into making things a little better. So what are the kinds of things that you would use scriptcs for? Experimentation. You just want to play around with some APIs. Console utilities. We saw how you could do that with arguments. Web apps. Some people are actually saying they want to use this for real web apps. They're saying they're simple web apps, internal apps, and they're fine with just using some script for doing it. And if that works for you, great. Web APIs, simple WPF apps, hardware automation, which just popped up. There's a sample there of using RavenDB for hosting in memory. But not everything in scriptland is pretty. So you have to deal with things like these using statements. Some of these actually now we provide you by default, like system.reflection and system.io. But if I'm using a NuGet package for the first time, I have to know exactly which namespaces have to be plugged in. Often, if I'm using frameworks like from Microsoft or from Nancy or open source, they may have their own template that does that for you. So that's a little bit painful. There's a bunch of boilerplate code you end up writing if that framework doesn't really work well with script because of things like dynamically emitted assemblies. And then there's just this kind of setup code that some of it is there today, but it's taken care of for you by Visual Studio. So for this reason, we came up with a concept called script packs. And script packs are NuGet packages, but they're able to make other NuGet packages easier to consume within scriptcs. They remove a lot of the monotony. A picture tells 1,000 words, so the best way I like to show this is let's take a look at the Web API script pack. So there is one for Web API, and there's a growing library of script packs. So if we go to the scriptcs repo, you'll see that there's a scriptcs Web API repo. So you remember that Web API sample I showed you before that had all those files, and we just reviewed some of the pain points around it? This is what it evaporates to if you use the script pack. So the key thing about the script pack is we've introduced a global function available within your scripts called require of t. And with require of t, you can specify a type, a generic type, which represents the script pack. And by convention, we will discover it. So as long as it's installed into the packages folder, we'll pick it up. And the script pack is designed to take you to the next step and say, okay, and it is very much inspired, by the way, from the node module system. If you look at node modules, you do a require, and you get back an object. And that object has functions on it that tell you how to use it. So what's nice about this is there's no more using statements that I have to manually deal with. I don't have to know objects that I knew up. I just need to know which functions the script pack offers, and the script pack authors can decide what that best experience is. One of the things you'll see here is also it's not just about usings. There's no longer any code that I have to write to register the default routes. That's actually taken care of for me by the script pack. I don't have to wire up that custom controller type resolver. That's taken care of for me by the script pack. So let's see how that would work. So I'm just going to copy this. You see it, so I don't need to write it again. Okay, so we'll go in here, and we will open up Sublime again. Sublime is nice because it will automatically detect that I created a new folder. So I'm just going to copy and paste that in. And I'm going to save that as start.csx. By the way, start.csx is just a convention. You're not required to do it. You can do whatever you want. We just said that that was easy and consistent. It is registered, actually. I have the license. I just reinstalled and keep forgetting to update it. And I've said that in about 3 talks recently. So, all right. So let's see how this works here. So if I just run it, it's going to fail because I don't have the script pack installed yet. But I install that script pack just like any other package. So I can say scriptcs-install scriptcs.webapi. And that should go out to NuGet and get the Web API script pack. Now what's nice is because it is its own NuGet package, it can pull in all the other dependencies that it needs. So you can see that it pulled in ASP.NET Web API, and it pulled in JSON.NET. It pulled in all the things that it would have if I just manually went and installed Web API itself. So now if everything worked, I should be able to just do start.csx, and it should tell me that it's listening, which it is. And then if I go here, and this time we did not use API as a prefix when we did the route. So we can see I got hello world. So script packs, they add reference assemblies. They add using statements for you. They make .NET libraries more consumable from scripts. And we saw that in the case of Web API, it did that by things like getting rid of boilerplate code, like registering the routes, as well as making sure that any pieces within the framework that didn't work well with the dynamically emitted assemblies got swapped so that they did. And these things are very easy to create. And just to put my money where my mouth is and to show you that, here is the Web API script pack. It's just a very simple C# project. And we've actually talked about allowing you to write script packs as script. That is something that's on the radar, because this is a perfect example of where you might say, why do I even need to have a project? So I have this class called script pack that implements iScriptPack. It's able to define the default using statements and namespaces that should be pulled in. And then the script pack itself, which is what is coming back with require of T, the same code is there. It's just now taken care of for me. I don't have to write it. Somebody else can write it. And if you come back to our scriptcs repo, you'll see we have a wiki where we list the growing number of script packs. You can see there are some for Azure Media Services, for example. The Southworks guys have actually written a script pack that makes it easy to talk to Azure Media Services. And they're actually planning to use it in a production environment with millions of videos and things. And I won't say any more. But you can see there's somebody's written, Philip, who's one of our contributors, has written one for NUnit. So I can run NUnit tests just from the command line. Instead of having to use the NUnit runner, I can just use a script for that. Service Stack, a whole bunch of others. And there are more on the way, and I would advise you all, if you want to do it, to feel free to jump in. And we actually have some posts and things on how to build a script pack, and it's really quite easy. All right, the last thing I want to show you, and we have like 2 minutes, so we're right on time, is hosting. So one of the things that people have said is, ooh, the scriptcs thing is really cool for running stuff at the command line. What if I want to actually host it within my own app? So one of the places this becomes interesting for is extensibility. Like imagine that calculator was a real app that was not a scriptcs app. It was an exe, a full project. It was a product that we ship. But we want to say to customers, hey, if you want to extend the calculator and add buttons or operations, all you've got to do is implement this interface. And we'll accept you doing that through scripts. You don't have to give us a DLL, just give us a script. And that is really easy for somebody who's like not a full-blown developer. Somebody who's just a tinkerer who says, oh, and often those kind of extensions are really small. They don't have a lot of code. So yes, you can actually host scriptcs. We actually have a hosting package, which is what scriptcs.exe uses. And one of the things this will enable you to do is actually host scripts within a full-blown IIS, ASP.NET application. You don't have to only use self-host. Because of lack of time, I'm not going to show that to you, but it totally is possible with our hosting package. So this opens up scenarios like adding support to your own runtimes, hosting scripts in a full-blown web app, hosting scripts anywhere. So scriptcs would not be what it is without all of the contributions. So this is an open source project. It's Apache 2. It is over 600 watchers, so it's growing pretty fast. We have 125 forks, 30 contributors. You're seeing some of them there. There's a core team of five of us actually, 3 who are kind of like the main dictators. And those are the top 5 that you see there: Damian Schenkelman, Philip Wojcicki, myself, Justin Rusbach, and Christian Helang. And you can find us on GitHub at github.com/scriptcs. So just going back to summarize what we've covered now, scriptcs is a tool which offers lightweight C# development, not a replacement for VS or PowerShell. It's useful for prototyping, tinkering, and automation. It offers both editor-based and REPL-style development, integrates with NuGet. You can host it within your own apps. It's open source, has a rich community, and is open for contribution. And here's some related content. And I would ask you, please, if you go to that Dev 309, which is Grant's talk, who's sitting in the front, he's going to use scriptcs his entire talk for demonstrating new features of Web API. You want to see this if you like scriptcs, because this is really real-world stuff that you can do with it. Please fill out your evals. Thank you guys very, very much for having me here.